And we're going to look at some composite functions on this video. Essentially, we are combining two functions. Right? From your notes, you'll see that you can use two functions to produce one function by combining them. In other words, you're going to put one function into the other function. Just like how you put a number into a function, you can also put an entire function in another function, right? Um, Putting something in a function simply means you're going to replace the x, right? So look at these two functions. We're going to find f of h of x, right? So find f of h of x. So I'm going to write f of h of x. What is that equal to? Right. This means that we're going to put the function h into the function f, right? F of h of x, what is it? Now, if f of x, now if you notice that f of x is 3x plus 7, so f of h of x would be equal to 3 times h of x plus 7. But we have an expression for h of x. So f of h of x is equal to 3 times h of x is x over 9 plus 7. That's the composite function there, right? Well, of course, we're going to try to simplify it. 3 can reduce 9, right? 3 into itself will go 1 time, and 3 into 9 goes 3. So f of h of x is going to be equal to x over 3 plus 7. That's it. So combining functions or making a composite function simply means putting one function into the other. So in this case, we want f of h of x here, right? So that simply means we're going to put h of x into the function f. Now let us find h of f of x and see. H of f of x. If you want h of f of x, now it means that you're going to put f of x into h of x, right? So h of x is x over 9. So h of f of x is going to be f of x over 9. See, I replace the x with the function because I'm putting the entire function into h now. But of course, we have an expression for f of x. F of x is 3x plus 7. So h of f of x is 3x plus 7 over 9. This is the combined function, and it's already simplified. So we don't want to simplify that any further. So h of f of x is 3x plus 7 over 9. Again, look at what we're doing. We're simply replacing the x with the function. We're plugging this function into the function h. So you replace the x. And there it is right there. Let's try a few more examples. Look at this. We have f of x equals 4 minus x squared. And g of x is equal to x plus 2. So let us combine these functions. I'm going to find f of g of x first, combined in this style. And then over here, I'm going to find g of f of x. F of g of x, I'm going to put g of x into f of x. That means this is going to be 4 minus g of x squared, right? So we have an expression of the g of x, of course. So we're going to have 4 minus x plus 2, that is g of x, right, squared. That is the combined function, but of course you can simplify this. You can remove the brackets, put the like terms together. So we'll have 4 minus x plus 2 times x plus 2. Remember, we've already combined the functions. Now we're just applying some additional algebra to simplify it. Okay? So this is equal to 4 minus x times x, that's x squared, and x times positive 2, right? That's plus 2x. And then 2 times x is plus 2x. And 2 times positive 2 is positive 4. Okay, so this is equal to 4. We remove the brackets now. There's a minus 1 outside there, right? Minus x squared This and this together is minus 4x. 2x and 2x, that's 4x, and of course we're multiplying by negative 1 because we're removing the brackets, and there's a negative 1 outside. Minus 4, alright? Notice we have 4 and 4 alike, one is positive and one is negative, so they will cancel each other, so your final answer should be negative x squared minus 4x. This is the simplified version of f of g of x. Right? Remember the function was already combined here. The rest of it is just doing some algebra to simplify it. Right? On the other side now we have g of f of x. Right? Now look at g of x. G of x is x plus 2. That means g of f of x is going to be equal to f of x plus 2. Right? And f of x, we have an expression for that. F of x is 4 minus x squared, and of course we're plus 2 like terms, so we have this is 4 and the 2 is 6, so we have 6 minus x squared. This function is a combined or the composite function g of f of x. Again, it's simply a matter of plugging in a function into the other function and simplifying, and this is already simplified, so that's a combined function there. Let's try another. These now f of x is x minus 1 over 2x plus 7. H of x is 2 minus 4x. Okay, so let us first find f of h of x. So f of h of x, we're putting h of x into f of x. So that's going to be equal to h of x minus 1. So you sub this x, there's another x though. So down here we have to have 2 times h of x plus 7. So just realize that wherever the x was, h of x takes its place. But we have an expression for h of x. H of x is 2 minus 3x. So we have 2 minus 3x minus 1 over 2 times 2 minus 3x plus 7. That's a combined function. And then you do some work to simplify. 2 minus 1 is 1, so we have 1 minus 3x in the numerator. In the denominator, we remove those brackets, so we're going to have 2 to 4 minus 2, 3 is 6, so we have 6x plus 7. And finally, we'll have 1 minus 3 in the numerator, and in the denominator we have 4 and positive 7 that are alike. 4 and 7 is 11 over 11. 1 minus 3x actually over 11 minus 6x. That's the composite function f of h of x. And then let us try to find h of f of x. So if you're asked for h of f of x, again you're putting f of x into the function h. We know that h is 2 minus 3x. So h of f of x is going to be 2 minus 3 times f of x. Right? You're going to write the expression for f of x, I should say. So we have 2 minus 3 times x minus 1 over 2x plus 7. Alright. So this will be equal to 2 minus 3x minus 3 over 2x plus 7. If you're asking the question, just remember that if you're multiplying a fraction by a constant, by a whole number, you just simply need to multiply the numerator by that number. Okay, so 3 times the numerator there will give us 3 times the entire fraction. Same thing. If you want to go further with this, you can write this as a single fraction by finding your LCD, which in this case is simple. In this case, the LCD is 2x plus 7, right? So 1 into 2x plus 7 is 2x plus 7, so you multiply that by 2. So 2 times 2x plus 7 minus 2x plus 7, this half equals 1, so minus 1 times 3x minus 3. You remove the brackets and simplify the numerator. And by the way, remember, we have h of f of x right here already. Right, that's it. But if you actually write it as a single fraction, then you can go further with it. Down here now, I will have, this is going to be 4x plus 14 minus 3x plus 3 all over 2x plus 7. And this is going to give you 4x minus 3x, that's going to be x. And 14 plus 3 is positive 17 all over 2x plus 7. This is the simplest it can go, right? This is the function here. This is the composite. Actually, this is it. I multiplied by the 3 there, right? And I decided to write it as a single fraction. So simplify it, and there we go. So guys, just remember that when you're combining functions, it's just a matter of putting one function into the other. You have the composite function there. If you're to simplify it, then that's algebra. That's algebra that you already know, right? So you apply the algebra that you know to simplify it.